Okay, so question 2. Jenny is investigating how many days per week people use the gym. She asked the 40 people in her fitness her data. So we've got the gym usage here on the x-axis and the frequency, so how many times this happens, along the y-axis. One of these people is chosen at random per week. So 2 days per week highlighted here, looking at the frequency, and that is 7 people. And that 7 people is out of the 40 people. What is the modal number of days to use the gym each week? So modal meaning the most common or the highest frequency. So we can hear that of 8 is for using the gym for 3 days a week. So the modal number of days is 3. Generally, there are a lot of people in her fitness group who are exercising less than 2 days per week, as there is a total of 10 people who use 2 days or 1 day per week. Explain why Jenny might not be correct. So you could have a variety of, you could have said that there are 40 people and only 10 do exercise on 0 or 1 day. 10 people is only 25%, or 10 out of 40 is not a lot. This only shows somewhere else. 30 people are exercising for 2 or more days, or more than 10 people use the gym for 2 or more. Question 4. Tachi collects data on the heights in data. Tachi picks one of these pyramids at random. Part A, find the probability that this pyramid will have a height. So I've circled all of the heights of more than 100. There are 4 of those out of a possibility of 7, so 4/7. The mean height of a sample of Mexican pyramids is 50. Pyramids are twice as high as the Mexican pyramids. Is Tachi correct? You must show working to support your answer. So, worked out the mean of the Egyptian pyramids by adding all of the meters found up here and dividing by the number of pyramids, which was 7. The second mark would be over here. The actual calculation answer would be 100.27 or 100.3 meters if you've rounded it to. Then for your third mark, to show that on average they are twice as high, I have multiplied the mean height of the Mexican pyramids by 2 to get 107 meters, or you could divide the 100.27 that we found over here to get 50.13, or you could divide that 100.27 by the 53.5 meters here to get 1.87. Any of these will get you the third mark. And then for your statement, the possible answers are yes, as 107 and 100.27 are similar. You could say no, no, as the mean for Egyptian pyramids is 100.27, which is less than 107. You could say no, as 100.27 divided by the 53.5 is 1.87, which is less, so incorrect. Our next question tells us the range of heights for the Mexican pyramids is 45 meters. The height of the Mexican pyramids is 30 meters. Work out the greatest height of the Mexican pyramids. Well, we know that the highest and lowest, so I've drawn a number line to show that if the lowest height is 30 meters and the difference between them is 45, 45 on to get a greatest height of 75 metres for the 1 mark. Question 6. Anna collected information about the 2022 season. The composite bar chart gives some information about the number of points scored by 9 of the teams. And we're shown this in the key here as well. Wraith Rovers scored 36 points from wins and 14 points from losses. So the first thing that I've checked is I've looked at the scale over here of points, and I've seen that actually each of the small individual lines must be worth 2. So if there are 36 points from wins, I've started off by showing that this scale here, my bar, is in line with the 36. The further 14 points here on the top for the points from draws, which actually takes me up to 50 on my scale, that one diagonally. It's important to note that you must shade the diagonals going in this direction and not the other direction. So that is 2 marks for a fully complete. What does the overall height of each bar represent? So 2 ways of explaining your answer. You could say or overall points scored, you need the word points there in your answer, or the points from wins and draws. We then have part C, which is asking us to compare the points scored by Dunfermline Athletic with the points scored by Queen of those 2 teams here on the bar chart. So it's important to say here, you don't actually have to show any numbers at all in your answer. At all. So the 3 possible comparisons that we could make here are points from wins, points from draws, and overalls. So my answers here, 1 mark for each of the relevant points, are that Queen of the South scored more points than Dunfermline Athletic, or you could explain that in the reverse and say that Dunfermline Athletic scored less points than the South. Second point, Dunfermline Athletic scored more points from drawing than Queen of the South, or the other. And finally, Dunfermline Athletic scored more points overall than Queen of the South, or the reverse. And that is for 3 points in total. Question 8. Timur is investigating the heights and internet about the heights and weights of players from the Wales rugby squad. The players from the Wales rugby squad are classed as forwards. Timur draws a scatter diagram for the heights and weights of some of the backs from the Wales rugby squad. The diagram is appropriate for the type of data that Timur collected. So any of the following for the mark. You could say the data is by variable. I need this bit of vocabulary as each person has 2 pieces of data. Or you could say it allows Timur to see if there is a relationship or association. And again, this is the vocabulary that you need for the mark. The data for diagram, the height and weight of each of these players is given in the table below. Part B, complete the scatter diagram by plotting the players A, B and C. So we can see that we have the height on the x-axis here, and if you look at the scale, is 0.5 of a centimetre, and the weight in kilograms is your y-axis, and that is going up in ones. Kilograms is this pink cross here. Player B, 183 centimetres, 87 kilograms is my green. And player C, 173 centimetres, going across here, and up to 78 is this cross here. If you get all 3 of those plotted correctly, that's 2 marks. 2 of them correct is 1 mark. Then for part C, we are asked to describe and interpret the type of correlation shown by the scatter diagram. So for 1 mark to describe it, it's a positive correlation, and the interpretation mark is that as the height increases, the weight increases, and that's for the 2nd mark. We're then told that the double mean point for the heights and weights of all of the backs is 184.92. And part D asks us to draw a line of best fit through the double mean point. So your 1st mark is for plotting that double mean point, and I have plotted it here. So 184 along the x-axis and 92 along the y-axis. So it's this grey one here. Then we're asked to draw a line of best fit through the double mean point. So I've made sure that my line has gone through this one. I've also made sure that when I've drawn it, that I've extended it across the whole of the graph, and that there are roughly the same number of points above and below. But there's a certain degree of accuracy that you would get for this, so it doesn't have to look identical for mine, and that is the 2nd mark. We're then told that Timur also collected the heights and weights of players from the England rugby squad. He found the Spearman's rank correlation coefficient for the heights and weights of the forwards from the England rugby squad. The correlation coefficient was 0.00. Part E, interpret this correlation coefficient in context. So first of all, there is no correlation because we have a correlation coefficient of 0.00. But to put it into context, we need to say there's no correlation between the heights and weights of the forwards. Timur used statistical software to find the following information about the heights, x centimetres, and weights, y kilograms, of the backs from the Wales rugby squad and the backs from the England rugby squad. And here's the table. So we've got our Spearman's rank correlation coefficient here in this column, and the gradient of the line of best fit in this column here. Part F, compare the Spearman's rank correlation coefficients and interpret this comparison in the context of the question. So firstly, to compare them, the positive Spearman's rank correlation, so I'm looking in this column here, and you could say between height and weight, is stronger for Wales than England. That's a comparison. 0.81 is bigger than 0.65. And then to interpret that, so that means the heights and weights of the Wales rugby squad are more closely related. Timur uses the information in the table to conclude that the weight of the England rugby squad backs increases faster than the weight of the Wales rugby squad backs as their height increases. Part G, assess the validity of Timur's conclusion with reference to the statistical results. So we need to talk about how valid it is, and we need to look here at the gradient of the line of best fit to help us with the statistics. So we could say Timur is correct as the gradient of the line of best fit of England at 1.02 is greater or steeper than our 0.96. This would be assessing the validity, and this would be referring to the statistical results. Or you could say that Timur is not correct as the gradient of the lines of best fit are similar. So as our two values are fairly similar, that could suggest that he isn't correct with his conclusion. So 1 mark for not correct and 1 mark to explain in context. Question 10. Matthew is investigating average household income for different states in the USA. Part A. Give a reason why it's appropriate to use secondary data for this. So we could say it would be faster, or we could say it would take too long to collect himself, which would be using primary data. We could say the data is easily accessible if we were doing this in a secondary data way, or not practical to do himself. Or you could say it would be cheaper, referring to using the secondary data, or it would be too expensive to collect the data himself. So any of those responses for 1 mark. Matthew creates a choropleth map giving information about the mean household income by state for the USA in 2023. And the household income is in thousands of dollars. So we've got our map here, and if we're looking at the key, it's telling us exactly how much the mean household income is for each of our states. And we also have a key over here for some of the numbered states. So the first question that we are asked about this is, which 3 states have the lowest mean household income? So we're looking at the key here for the states that are unshaded. So we have 2 of these named here, one of them labelled as 10, so we needed to look over here to find out which state that was. So the answers for this were, for 1 mark, West Virginia, Mississippi and Arkansas. Matthew concludes that the mean household incomes are highest on the West Coast and the East Coast. Does the choropleth map support this conclusion? Give a reason for your answer. So the possible answers here would be, firstly, Matthew is correct. The darker shading is on the West Coast and the East Coast. So we can see here the higher values that from our key are the darker shading are on the West and the East. I've done a little compass map here to help me with the directions. So that would be for 2 marks. We could say that Matthew is correct because the lowest mean incomes are in the centre. So if we're looking at the lower shading and the dots, that's more central. We could say that Matthew is incorrect. Colorado, which is shown here, is also high income and in the centre. So any of those responses there for 2 marks. Question 12. Cartier organises 2 different training courses, Course A and Course B, to help people to learn to type. She wants to compare the 2 different courses to see which is better. At the end of each course, the people are given a skills test. The table shows the number of participants who passed and failed the skills test for each of the 2 courses. So we've got this table here. We've got the number of people that passed on each of the courses, failed, and the total number of people here that took each of the courses, 50 for Course A and 80 for Course B. We're asked Part A to find the relative risk of failing the skills test having taken Course A compared to Course B. Excuse me. So we're first of all looking at Course A for 1 mark, and we're showing that 15 people failed out of 50. So we have a fraction of 15/50ths for the mark. To use the formula correctly for relative risk, we're then dividing that by the number of people who failed Course B, which was 32 out of a total of 80. So 32/80ths. So that's 2 marks there for using the formula, and the 3rd mark for getting the result of 0.75. So 0.75 being the relative risk. We're then asked for Part B to give an interpretation of our answer to Part A of being 0.75. So you don't need to actually put any numerical results at all in your answer. You're just giving a worded interpretation. So this mark could be gained by saying either the risk of failing the skills test having taken Course A is lower than the risk of failing having taken Course B. So I can see that at 0.75 it's actually 25% lower risk. But you don't need to show that value. Or you could phrase that the other way around and say that people who take Course B are more likely to fail than those who took Course A. It would actually be 25% more likely, but again, you don't need to say that data. So that's the last question. Well done.